That now brings us to the point slope formula. Any line can be found if you know the point and you know the slope. 2 bits of information, you can find the equation of any line. And there it is. And if you look at it closely, all it really is the slope formula, just rearranged. They got rid of the bottom of the fraction, multiplied by the bottom. So y minus y1 is m outside of x minus x1. Here we go, find the equation of a line going through these 2 points. Aha, got to find the equation of a line. I need 2 bits of information. I need a point, I need a slope. I got 2 points, excellent. Slope, no, haven't got a slope. So before I can do the question, I got to find the slope. But we got a formula for that. Difference in the y values over the difference in the x values, making sure we keep it in the same order. I've gone with the first point. So 4 minus 6 becomes 4 plus 6, minus 3 minus 2. Okay, we now have a slope. We got a point, we got a slope, put it in the point slope formula. Y minus 4 is negative 2 outside of x plus 3. Expand out, I've put it in general form. 2x plus y plus 2 is 0. I have the equation of the line passing through 2, negative 3 as parallel to this one. Okay, I need 2 bits of information. I need a point, I need a slope. I got a point. Slope, haven't got a slope. But it's parallel to this one. And we know if they're parallel, they've got the same slope. Okay, let's work out the slope. If I rewrite it so it's in that y equals mx plus b form, a lot easier to see the slope, minus 3/4. So the one I want's minus 3/4. Put it in the point slope formula. Again, I'm going to go general because I just find it easier. Get rid of the fraction, multiply everything by 4, pull everything to one side, and there we go. 3x plus 4y plus 6 equals 0. That now brings us to an easier way to solve this problem. Have a look at the question, have a look at the answer. And what do we notice? The coefficients of x and y are the same. They have to be, they've got the same slope. So really it's just a number. Now if I know that, I can do it this way. I could say, well hang on a sec, it's parallel to this line. I know the coefficients of x and y are going to be the same. Therefore it must look something like this. 3x plus 4y plus some number is equal to 0. I just got to work out what that number is. But hang on, I've got a point. I'll just substitute it in and see what happens. So substitute in 2, negative 3. Let's work out what k is. K is 6. Well, there's my line. 3x plus 4y plus 6 equals 0. So it's using the pattern where we can solve it a little bit quicker. And we can do the same with perpendicular lines too. Let's have a look at this. It goes through 6, 4 and it's perpendicular to this one. Do it the long way first. Okay, point, slope. Need to find out a slope. So I'll rewrite it y equals mx plus b. The slope of this is 9 over 4, but my line's perpendicular. So the slope I want, turn it upside down, change the sign. Minus 4/9. Point slope formula. I've got it in general form. Now have a look, compare the two. What do we notice? The numbers have swapped over, but the sign in the middle has changed. Makes sense. Slopes are negative inverses of each other. So all I've got to do is swap the numbers, change the sign in the middle. So if I know that, I can say, well hang on, this one must be in the form 4x plus 9y plus some number is equal to 0. Because it was 4 in front of the y, forget about the sign, 4 was in front of the y, so now 4 goes in front of the x. 9 was in front of the x, so now 9 goes in front of the y. Instead of a minus between those two, I've got a plus in between those two. I just got to work out what the number is. They've told me it goes through the 0.64. Sub in, and we get k is negative 60. There's our answer. So again, can save us time. How do we prove 3 lines are concurrent? So concurrence means all 3 lines go through the same point. So the collinear we saw before was 3 points on the one line. Concurrent is like the reverse of that. Lines going through the one point. So what would I do? I would find the point of intersection of 2 of them. So I just pick 2 of the lines, let's say L and M. Solve them simultaneously. That gives me the point of intersection of 2 of the lines. So then that other one, N, I didn't use. Let's put this point into there. Because if that point lies on that line I didn't use, then I know all 3 lines go through that point. because it's the point of intersection of the first two, but now I know it also is on the third one, and that will prove it. So if it satisfies the equation, then yes, those lines are concurrent. Okay, let's add 17 to the mix.